Everyone, welcome back to SAT Math Question of the Day. Here's our question of the day. Please try it. Pause the video, come back, and we will go over how to do it. Okay, a 40 milliliter bottle of pre-diluted tea tree oil contains a 5% concentration of the active ingredient, which, by the way, reduces, which headlights don't like. If the seller charges $14.96 for the total amount of the active ingredient in the bottle, what is the price per milliliter of the active ingredient? Uh-huh. Huh. Okay. So it looks pretty straightforward. The price per milliliter. Well, if it's 40 milliliters and it's 5%, that means that 0.05 of 40 is the active ingredient. So that's pretty clear. So we could do that. Calculator. I know we're not supposed to use a calculator, but it's like 8 something.
So
right?
how much of an active ingredient?
Yeah. So let's just get that. That's 2.
So you say 0.05 unknown times the unknown. How much of the active? 0.05
of 40. So it's 0.05 times 40 is 20%. It's 1/20th or 1/20th of 40. It's 2 milliliters of the active ingredient.
Yeah.
Now the question is, what do we divide that by? So if the seller charges $14.90 for the for the total amount of active ingredient in the bottle, what is the price?
Well, you said you don't divide that by anything. They're interested in the price per milliliter of active ingredient, and they give you the price of that quantity of active ingredient. And so what you do is you take the price of that quantity, which is
$14.96.
2 milliliters, divide that by the amount of quantity, 2 milliliters, and you get the price per milliliter. So you divide $14.96 by 2 milliliters, and what you get is dollars per milliliter.
Oh.
Which is what you wrote.
Yeah. It's pre-diluted, which means that it's concentrated.
No.
So, a 14 milliliter bottle of pre-diluted tea tree oil contains a 5% concentration of the active ingredient. So it's still sort of diluted, right? It's not pure tea tree oil because it's. Am I reading too much into it? Anyway.
Yes.
Yeah. But if the seller charges $14.96 for the total amount of active ingredient, I don't know. I'm getting a little. Yes, I think you're right.
Well, I think you're reading too much into it because.
Yeah, I'm reading too much into it.
The seller charges that much for the active ingredient,
right?
But
for the active ingredient.
Is that different from saying that the seller charges $14.96 for the bottle?
We don't know.
However, so if the seller is charging $14.96 for the bottle with the diluted tea oil, then he's charging that money for the bottle itself, plus the active ingredient, plus the dilutant.
Right. Yeah, that's why they have to say $14.96 for the total amount of the active ingredient. That's why they have to make that clear. But it is a little strange, don't you admit? It is a strangely worded question.
Yes. To say $14.96 for the total amount of active ingredient.
That is a
what we are interpreting that is $14.96 for the packaged bottle, and the question is asking what is the how what is the only the way to buy the active ingredient is the only way to buy it is with the whole bottle.
Right.
And they're asking for the unit price of the active ingredient, which you get in the bottle.
Right.
Yeah.
Yes. That's right. Yeah. Okay. Yeah.
So I think our best guess of the interpretation is the one you wrote down.
Yes.
So let's discuss how to do it with a calculator, and then see how see how our response compares with Khan Academy's.
Yeah. Well, yeah. You have to know that a 5% concentration in 40 of a 40 milliliter container, or in a volume, if you have a volume of liquid and 5% of it is active ingredient, you multiply the 5%, which is 0.05 times 40, to get the amount of active ingredient. 2 milliliters of actual pure, absolutely pure oil. Yeah. And this is a percent problem. If you wanted to do 6% of 20, you multiply the 6%, 6 over 100 times 20. So, and then you have to divide by 2, which you could do with a calculator. You can do this with a calculator, or you could do this with a calculator, or just divide 1496 by 2. Either way. Yeah, I mean the percent problem is I like to think of it as an is over of, is 5 over 100, is the percent over 100. It's an of, the of is 40. So what is means x, of is 40, p is 5, and 100 is 100. And you solve for x, and you see that x is 2. If you do it with this formulation, which is a really good way of doing it.
Well, it's better to merely understand what it means.
Yeah, in the of case, yeah, but the opposite percent.
That 5% of 40 milliliters is, the fraction that 5% means, which is 5/100 or 1/20 times 40 milliliters.
Yeah, but if you have the backwards question, then this formula really, this relation really helps you. If you
we have a forwards question.
I know we have the forwards question, so we're not going to talk about the backwards question. Now, maybe we will. The backwards question is if they tell you what the 2 milliliters is, and they say 2 milliliters is 5% of what number, then this relationship really comes in handy. Okay, without any further ado, we're all dying to know whether this is right.
I'm not dying to know.
Okay, so it was 748, right? I'll check calculator, 748. Okay, let's see. Check. Okay, great. So let's see how they interpret it. So let's make this font a little smaller. Let's get all the hints out, and let's see how they think about it, how they are doing it. Let's start by finding how milliliters are actually in the bottle. Fine. So they do that. Okay. So they don't really explain the second part of this step. They just do it.
Yeah.
Which is not great. Now let's find the price per milliliter of the active ingredient. This is the unit price. The bottle. That's interesting. Look at what they say. The bottle costs $4.96. For 2 milliliters of the active ingredient.
Yeah.
Yeah.
That's our so what they're doing is looking at the price to get 2 milliliters of active ingredient.
Right.
But for the same price, you also get the diluent and the bottle.
Yeah, you get 38 milliliters of the other stuff and the bottle.
Yeah. So I think the question is sloppily formulated.
Yeah, isn't it? I think so.
Yeah.
Yeah, because if
one could read into it, what does this kind of a formulation suggests or would apply to what is the cost to the manufacturer of the active ingredient. So the manufacturer, who dilutes the active ingredient and manufactures or buys the bottles and packs them and ships them and all that stuff. There's a cost to the manufacturer, and the manufacturer presumably buys or incurs costs
we don't care, Seth.
to manufacture the active ingredient, but there's no information in the problem is about any of the cost to the manufacturer. The only information is the cost to the consumer.
Okay, forget the manufacturer. That's not the problem. The problem is that there's an inconsistency. Look. It says right here. This is really annoying. For the total amount, it's $14.96 is for the total amount of active ingredient in the bottle, right? Right? But the answer says $14.96. Where was it? That's fine. The bottle costs. That's different, isn't it? Technically?
Yeah, that's my point. The bottle
costs. That's different than. Wait, let's get them all in the same. Wait, hold on. There's some problem here, but I guess we should just say goodbye to it because this is really
So what's the moral of this story?
Take a chance. You just figure out what you think. They try to guess what they think. Try to get yourself into their shoes, but don't read too heavily into it. But this is a problem.
Yeah. So I think the moral is
the bottle costs
is when a problem is poorly formulated, and you encounter it on the SAT, and you're trying to answer it, make the simplest reasonable reformulation.
Yeah.
So I wonder if the actual I would think at this point the actual SAT questions are more carefully vetted.
Oh, absolutely.
Than these con questions.
Of course they are.
So that's it's one of our we have identified another approach to using the con questions to study for the SAT.
Yeah, what's that approach?
The approach is to not get frustrated in your studying by con questions being sometimes, less rigorous.
Yeah.
There's some assurance if you run into these frustrations if a con question has if you think about it, it says things that don't make sense.
Yeah. Yeah. Yeah.
recognize that they sometimes don't make sense.
Right. Right. Yeah. Understand.
However,
Yeah.
realize, right, don't worry about it because the actual SAT questions are better vetted.
Right. Yeah. So that leads to the approach to studying is go to Khan, take their course on the digital SAT. They essentially tell you what's on the test. About 600 or 700 math questions, probably the same for English. Learn what's on the test, review what's on the test, relearn what's on the
Yeah.
test because hopefully you learned it in school, and then go to the SAT practice test and take all of the practice tests they offer so that you can get a sense to what the actual SAT questions are. And that's a great way to study.
Yeah.
And
Okay.
yeah, so just introduce ourselves and we're basically done. This is
Yeah.
Seth. Seth, you were going to say something?
Yes, yes,
Okay,
yes.
what are you going to say?
I see what we're doing is giving approaches to besides taking the SAT and doing well in the SAT, approaches to schoolwork and learning,
Yeah, yeah,
which are approaches that are useful, especially when learning becomes more intense when you get into college.
yeah.
So the approach I will add to my list is
Okay.
oh is be critical, which means which means formulate criticisms to yourself and discuss them with friends of ideas and particular situations that you observe in your studies.
Yeah,
And
yeah,
this attitude of being critical
yeah,
approach to school by seeking inconsistencies, problems, contradictions, disagreement
yeah,
with what people say or write is what college is something that's very is a big part of of being in college.
yeah, yeah,
And as Joel wrote, ask a lot of questions.
yeah, yeah. And what you just said is be critical of question things that don't make sense that other people write. Question things that you write that don't make sense. And you've seen that multiple
Yes.
times, especially with me. When I'm solving the problem and I see something, this just doesn't make sense. You do the problem two different ways, you
Yeah.
get different answers. Yeah, you gotta resolve all differences. You gotta resolve all everything should confirm and make sense to you, even things you write yourself.
Well, sometimes, but the fact is, it's common at least at first, and sometimes never, uh, figure out a resolution or solution to a contradiction or something that doesn't make sense. Something may not make sense. Something that doesn't make sense. You might never find a reformulation or guess. Never find a different thing that purports to be similar to the thing that doesn't make sense. It does make sense. So in
That's
other
true.
words,
That's
in
true.
college and in life, you're seeking of asking a question, right? You could ask questions it's good to ask a lot of questions. Sometimes you will figure out or find out from another source what the answer is, and sometimes your question will remain unanswered.
Yeah, okay, but in high school, that doesn't happen that often. But what could happen in high school is you can get different answers to the same question.
Yeah.
Sometimes textbooks will have the same problem and will have different answers to the same question. At
Yeah.
that point, I take the practical approach because I have a PhD in mechanical engineering and so there's a PhD in math to answer it the way the teacher wants you to answer it. If like the textbook has two
Yeah.
different ways of
That's
answering.
an approach. And that applies to college also. That applies to college
Okay,
also.
okay,
That sometimes the approach to success in college is to figure out what the teacher wants and give that answer. And success is measured in terms of what grade you get.
right, right.
And the
So
problem is, students miss out on the benefits of college education later when that is the only approach that they use. Too many students approach college only that way, to only strive to figure out what the teacher wants and then give the teacher what he or she wants.
right. So let me give a beautiful example of this, and maybe Seth has an opinion. If a graph is increasing and reaches a top, and this
Yeah,
x value is 4, and this point here that it reaches the top, x value is 7.
yeah,
And let's say it starts here and it goes up and it's continuous, right? It just keeps going. What
continue. Yeah,
interval in x is it increasing? Some people would say certainly x is between 4 and 7, and other people would say x is between 4 and 7, not including the 7. I've seen it both ways. Interval
oh,
that x is increasing.
interval.
That x is increasing. I
So,
think
so the issue here, so the way to answer this is the function increasing at 7?
right. You would think it's not.
So the interval, the only way I can make sense of this, no, actually, uh, no, I was wrong. To say that a function is increasing over an interval means, again,
I know.
I think it's ambiguous.
Right.
It's ambiguous, and there are two definitions of increasing. Increasing is a property of a function, whatever that means. So we could say one concept is a function is increasing at a point, right? And then you say, well, is the function increasing at all the points in an interval? That's one concept. So for every point in the interval, is the function increasing at that point?
Okay.
That's concept one. Concept two is that when you pick any 2 points in the interval, any 2 points, both of them being in the interval, and the first is less than the second, we say this is a concept that pertains to pairs of points. And we say a function is increasing on a pair of points when the pair of points is they are distinct. Say the first one is less than the second, And then the property means that the value of the function at the first is less than the value of the function on the second.
Okay, so at that point,
And then you could say the function has this property over the interval when for every pair of points in the interval,
yeah,
is it increasing over that pair of points?
got it.
And so the second formulation says nothing, is not in terms of is the function increasing at a single point.
Right, got it. Got it. Yeah.
Yeah,
So
and
here,
if under the second conception, it is true
yeah,
that the function, the second property is true over the closed interval from 4 to 7.
right, is between. So what
Yeah.
what are we really doing here though? We're between 2 points. So what we're really doing here is we're really taking an example where if you look in different books, you get different answers, and then you have to
Yeah.
but then you have to
Yeah.
ask yourself what is going on.
That's the problem. The problem there is different books, and perhaps even in the same book, have weak mathematical quality in that their definition of the words are different.
Got it. So, but the bottom line is that if you're interested, if you care, other than just let's say you really care. I mean, to answer this question on a practical point of view on a test is you ask the teacher, what do you say? And whatever the teacher says, you say. Okay, that's what you do just to get through the test.
Well,
Care,
what the teacher ought to do in a situation like this, what the teacher ought to do is declare what the definition of these words is. Of course, that's in the context of the class.
No.
However, to many teachers not quite that great in the foundations of mathematics.
So no. So what do you do? You ask the teacher which way to answer the question. You get the question right, and then you go back and you say to yourself, I am not satisfied with what the teacher said. I really want to know why, not just the teacher says do this. Then you got to ask more people. Then you got to keep going at it. At some point, you may not really care. I mean, this is a fairly minor thing in the scheme of things. But the idea is that if you care, you have to go and really search it out. And you got to find someone like Seth who explained it quite well, that it depends on the definition of increasing. It depends, which is a good, really solid answer. It depends on how you define increasing. And I hope Seth explained it pretty clearly. That's pretty good.
Yeah. Well, the first definition pertains is relevant when we have calculus.
Of course.
And that there you need to suppose that the function not only is not just continuous but differentiable.
It is.
Which means it has a derivative, whatever that means. And then the concept is the function's derivative positive?
Exactly.
At a point.
Right. So
and then in this case, the function you wrote, the derivative at x equals 0, at x equals 7 is 0.
Absolutely. So that could be an argument why this would be the answer in a calculus book.
Yeah. But a good calculus textbook would distinguish between the concept of a function having positive derivative in every point at an interval, and the word saying a function is increasing,
right,
within an interval.
Yeah, well, it depends on how you define increasing. It sounds like.
Yeah. No, I think that a careful calculus textbook would use our second definition for increasing within an interval. Yeah. In fact, in other contexts of mathematics, when we talk about general orders,
Yeah.
we say that a function is the only way to generally say a function is increasing is the second. That for every pair of points, if every pair of points x1 and x2, if x1 is less than x2, then f of x1 is less than f of x2. And that's called strictly increasing.
Right.
There's another concept called weakly increasing.
Yeah, we're not talking
which
about
goes
that.
if x is less than or equal.
We're not talking about
x1 is less than or equal to x2, then f of x1 is less than or equal to f of x2.
Right. Yeah, unfortunately, this is a really good calculus textbook. Stewart, classic, big book. I mean, look at the size of this thing. They talk about increasing. I don't really care what the definition is. I just want to see what their answer is.
No, look it up in the index and tell me.
Well, they say a function. They do this even before they do calculus. This is in the page 19, even before calculus.
Okay, read it.
They say a function is increasing if on an interval if a function f is called increasing on an interval I if f of x1 is less than f of x2 whenever x1 is less than x2 in I. So that's the second definition. So that's comparing 2 points.
That is, okay, that's what I figured.
That is comparing 2 points, right. Yeah.
Well, the concept of increasing on an interval is that for every pair of points in the interval.
Right.
We have that property.
Yep. And then somewhere in here, there's maximum, minimum. Yeah, they don't really talk here about where the function is increasing or decreasing. Wait, maybe they do. Anyway, I don't want to waste people's time.
Yeah, and in fact, that definition applies any function, including those that are not continuous. That makes sense for even non-continuous functions.
Right. Yeah, they don't say. I'm just looking quickly to see if they have an example of where function is increasing and decreasing. Just as an example, I don't see an example where they have intervals. So I'm not going to waste anyone's time.
Okay, good.
Okay, great.
Good.
Okay, good. Okay. So anyway, but the idea.
Okay, what approach? What? Approach to school and college? Don't. The approach to school and college is when you formulate a question to yourself, you try to answer. Don't say, I don't bother with that. Especially if you have the answer right in your pocket. Look it up in the index and see what the answer is.
Okay, so now, wait, example 1. Yes, there's an example here. And it is this example. Okay, there is an example in the book. And it's this weirdo, this is strange function. I'm just going to graph it, okay? It's got an asymptote here. And the function is this. It goes here, and it goes like this, and it goes like that. Okay? Okay. And the actual function, if anyone cares, is 2x squared divided by x squared minus 1. Come on, stop.
Okay.
Come on. Why isn't it working? Anyway, x squared minus 1. Now, here it is. Part E.
Okay, it's has 2 asymptotes.
Oh, there's no asymptote.
When x is, it's singular at x equals +1 and -1.
Oh, wait. They changed it. Oh, my God, I'm so sorry. No, they didn't change it. I misread it. Of course, it's my mistake. It's x squared over the square root of x plus 1.
Yuck.
Okay? Now, here it is.
Okay.
Here it is. E. We see that when f prime of 0 is 0, when x is 0. Okay. No, okay. Okay, notice, since, they say that f is decreasing. F is decreasing on the open interval,
Yeah,
-1 to 0.
yeah.
Oh, 0 is open, and increasing on 0 to infinity. So they do not have it closed. They do not include 0 as where it is decreasing. So they are saying it's decreasing
Well, it's true.
from 1
It
to
is
0.
true.
X is
Okay, my point is, it is true that the function is decreasing over the open interval from -1 to 0.
yeah, but you said that.
Hold on.
Okay, go ahead.
It is also true
Yeah.
that the function is increasing on the half open interval, x greater than -1 and less than or equal to 0.
Say that again.
It is all, the first statement is what Thomas wrote.
Yeah, f is
The
decreasing.
second statement is imagine what Thomas wrote, except the interval is open at the left side and closed on the right side. In other words, the interval includes 0.
Right.
His definition is satisfied over this slightly larger interval.
I still don't understand. If you said that his first definition was a 2-point definition of increasing,
Yeah. The issue is,
then this seems to be
in this first definition, the second of the 2 points cannot be 0. In the first definition, at the open interval, the second of the 2 points cannot be 0 because 0 is not in the open interval. In my second definition, the second of the 2 points might be 0.
I don't know. Now you're confusing me. I don't know.
You're just not listening. So use a different color.
Yeah.
And make a blue dot at the origin.
Fine. Make a blue dot at the origin. Got it. There's a nice blue dot at the origin.
And now make another blue dot a little bit to the left of the origin on the curve.
There.
Okay? Now, what's the value of the function at the left blue dot?
A little bit bigger than 0.
And what is the value of the function at the blue dot?
0.
Okay, is a little bit greater than 0. Let's see, greater than 0.
Yeah. A little.
Is it? Yeah.
Yeah.
Is the x value of the blue dot to the left less than the x value of the blue dot to the right?
Is the x value of the blue dot to the left? No, it's greater than.
No, don't draw another one.
Fine.
X1 is the leftmost blue dot.
So can
is the x coordinate of the leftmost blue dot.
So can I label x1?
Yes. And x2 is the x coordinate of the origin.
Fine, x2, got it.
Yeah, x1 is greater than x1 is less than x2, correct?
Yes, x1 is less than x2.
Now, is f of x1 greater than f of x2?
Absolutely.
And so over that pair of points, the function is decreasing.
That's right. That's right. That's right.
Now, so that is a condition that is included when Thomas's definition is applied to the interval that consists of all the points above -1 up to and including x equals 0.
Okay. Yeah.
The open interval consists of all the x values that are greater than -1 and are negative.
Okay.
So those are so the open interval does not include x equals 0.
Look, all I'm asking is what interval is it decreasing? And when
It's I say the largest interval over which it is decreasing is the half open interval that's open at -1 and closed at 0.
Okay, so that would have the equal sign on 0.
Yeah, that would, and it's usually denoted instead of a curved parenthesis,
Right.
a bracket.
Right.
Where
right.
Yeah.
Yeah. So it's negative. And this is -1. -1, 0, like that.
That's right. Yeah.
Now I guess we're not even talking about this. By the way,
however,
it's not Thomas,
since the property is true, what property about it decreasing on a set by by the logic of it, if a function is decreasing on a set, it's also decreasing on every subset.
Right. Okay.
And the open interval is a subset of the close of the half open interval.
I'm just looking for an example now. Thomas, which really is, by the way, there was Stewart's F. It wasn't Thomas. It was Stewart.
Stewart. Okay, Thomas Stewart. Yeah.
Yeah. Okay, B. Okay, here's another one. Here's a polynomial. B. Find the intervals that it is. See? Thomas. We see that. Wow. Now, this one is. Yeah. So what did Thomas do? Thomas, the other book this Seth is referring to, by the way, we did Stewart. Now let's bring in Thomas. Thomas is playing with this one. X to the 4th minus 4x cubed plus 10. So this is what's known as a quartic. And it goes up to infinity. It crosses the axis. It goes down. It hits a thing at 3. Okay. Thomas says, in his question, find the intervals on f that it's increasing and the intervals on which f is decreasing. Thomas's answer is that it is decreasing from -infinity to 0, which is this way, right? And then again from 0 to 3, including 3.
Yeah, that's right.
Including 3. So we have a different answer between Stewart, which is a really big, thick book, and we have a different answer with Thomas, which is also a really big, thick book. Same question.
Well, who's the one with the open interval? Well,
that's Stewart.
Stewart's statement is true. What he wrote is true. What he neglected to write or say is that a stronger conclusion is also true.
Hmm.
Now, what Thomas did was answer the maximal intervals, the largest intervals over which the function is decreasing on the one hand, one question, and increasing other question. So he asked a different question. The maximal intervals with a property, the answer that Stewart gave was an example of an interval with a property, but not an example of a maximal interval with a property.
Yeah, but wait. But if you're reading the book, you don't know that. You have to really question what is going on. You have to really get down to it. You have to talk to someone
Yes.
who can
Well,
explain
the wiser student will not be one who ignores that when reading the book.
But yet again, if you're taking calculus and you've only taken one, and you only have one book, then you are not going to know that there's a question here, right?
No, you will know if you think about it.
Well, yeah.
You'll figure it out. You will criticize what you're reading and ask yourself, "Hey, there's something missing here."
Yeah, like, do you include zero?
Yes, you will ask that question yourself.
Or zero.
Even if you're a student who's getting the most out of college, when reading a book like Stewart, would say, "Hey, there's something missing here."
Or Thomas. I mean, you have to question it. Why are you including?
Well, Thomas maybe calls for less questioning because Thomas gives, in a sense, a more complete answer.
Yeah, but you could certainly make the argument. Now we're talking about calculus. I'm sorry to anyone who hasn't taken calculus yet.
Actually not.
When
no,
the
but go on.
If the derivative is equal to 0 at 3...
we could avoid talking about derivatives.
Okay, fine. So the slope, right? It hits a bottom.
No. We're talking about increasing or decreasing over an interval.
Right.
Which is a definition that applies no matter what.
Right, that's true.
No need for concepts of derivatives or continuity.
Anyway. So the bottom line is be critical, and you're learning something. Question everything, and then just keep going at it, and just keep asking till you get satisfied. So
yeah. So the thing is, many students would read Stewart and not realize this issue. But that many students is not the same as all students.
Of course. Yeah.
You made a statement that everyone reading Stewart would not see this.
That's true. I'm sorry. Yes, you're right.
I accept your apology.
Some people reading Stewart would say, "Hey, I'd like a better answer. So please explain this to me."
What kind of person would you prefer to be in the audience? Would you prefer to be a person who reads Stewart and gets nothing and observes nothing about an unanswered question? Or would you rather be a student who reads Stewart and says, "Hey, there's something missing here"?
No, there's a big argument for not caring less and just getting the answer and doing well on the test and moving on. Because
there's a big argument, but it's an argument that leads people to achieve much less of their potential.
Even if they're not math majors.
You want to achieve less than your potential?
No. Okay, right. Even the thing is, though, there's a priority. If you're, let's say, a psych major or you're a political science major or an economics major, maybe you want to spend your time questioning things in economics that don't make sense to your economics professor and not spend your valuable time questioning something in calculus that may not make the most sense. There's a question of priority. People have limited time. But the idea
Well,
is the
economics.
question. The idea
Economics,
is,
yeah, economics uses calculus.
yeah, and whatever you care about, whatever you really care about, really question everything and make sure everything makes sense to you. And if you have questions, that's a good thing. And keep at it till you get a sufficient answer. And yeah, it's good practice to do things even if you don't care about them, just for practicing the idea of questioning and figuring out how to get an answer if you don't necessarily care that much. But then that's just practice for making sure you do this for things you do care about. Because that's when you only have the energy to sit here for 50 minutes and actually discuss this. I don't think if you really care. So, okay, anyway, I think we are so done. We are so overcooked here.
Yeah, we got to the conversation.
We're totally burnt here. We're like burnt to a crisp.
Yeah.
So anyway.
Well, it illustrates the differences, our differences as brothers.
Definitely, that's who we are. We're brothers. Seth, I think we met before.
Yeah.
Seth is a PhD in math from MIT. He's a professor emeritus at SUNY Albany. Has been teaching there many years. Joel, I have a PhD in mechanical engineering, a little more practical approach, but still, if something doesn't make sense, you got to question it. And we try to do this every day. Tomorrow's Throwback Thursday, so come and join us tomorrow. And if you have any math SAT questions, please email them to us at satmathquestionoftheday@gmail.com, and we'd be more than happy to do them here live online. Okay, everyone, I guess have a great day after this discussion. Okay, everyone, bye-bye.
Bye-bye.